Hello everybody, welcome to section 5.1. We're beginning chapter 5 when we're going to be talking about some polynomials. So an introduction is in order. And in this introduction we're going to be talking first of all about some basic definitions dealing with polynomials. And we'll take you through some steps dealing with how we work with polynomials in terms of addition, subtraction, and evaluating polynomials and what that means. So let's start with some definitions. Of course, one of the first things that we need to know is what is a polynomial. And there are different kinds of polynomials, but essentially a polynomial is defined as a set of terms with variables, real coefficients times variables raised to positive integer exponents, right? So the two keys from that to keep in mind when we are talking about what we mean by a polynomial is that any time we deal with a polynomial, two things are always present. We have real coefficients. Remember that a coefficient is a number that is multiplied by a variable. So real coefficients, spell coefficient correctly, real coefficients. And we have positive integer exponents, whole numbers. Right? As long as those are present, basically what's going to happen, your terms are going to be polynomial terms. So what kind of polynomials are there? Well, the most basic kind is a polynomial that has one term only. I'll give an example of a polynomial with one term only, 3x squared. If I just had the term 3x squared, this is going to be a monomial. A monomial, of course, the root of that word is mono, meaning one. And of course, you guys are probably familiar with the term binomial. If I wrote x plus 2, it's got two terms, right? Terms, remember, are parts of an expression that are added or subtracted to other parts, right? So don't forget that word terms from when we talked about it earlier in this book. Terms are specifically, in algebra, parts added or subtracted. Added. Boy, I can't spell today, huh? Let's try that again. Added with two D's and subtracted. Fun. There we go. Okay, now I feel a little better, even if I can't write nicely. There we go. Added or subtracted, right? So there's two terms in our binomial. We could also write anything that has two terms in it. I could say, well, if I had 3x squared y minus 6y squared, it would also be a binomial, even if we have two variables in there, right? We can have as many as we can fit. Trinomial. Trinomial, of course, tri means 3, so we're going to have something more along the lines of, let's say, x squared minus 4xy. Let's try that one. Plus 4y squared would be an example of a trinomial. When we say polynomial, what do we mean? Well, we have one term, two terms, three terms. Do we have an extra one for four terms? Yeah, the answer to that is no. It just goes to polynomials. It's like counting 1, 2, 3, many. After that, we just say there are many terms, right? So a polynomial, that's what we're going to talk about below. And of course, r of x right here, this is an example of a polynomial. And so is this thing down here. Now we'll talk about these in a moment. But when we say a polynomial in x, a polynomial in x is an expression that contains only the variable x. So a polynomial in x means it only contains, good lord, that should be contains, right? It doesn't look much like contains. Come on, Mr. Peoples, learn to write. Contains variable x only. So if you look at our trinomial right here, this would be a polynomial in x and y. Our monomial would be a polynomial in x, as with these functions down here. The degree. What is the degree? The degree is the value of the highest value of the exponents in all of the exponents in your terms, right? So the degree, that's our highest exponent in all of the polynomials expression. Highest exponent. Right? The leading coefficient. The leading coefficient, unlike what we say right here, right? Leading, we think leading, well, that's the first term. But no, in fact, when we mean leading coefficient, we mean the coefficient of the highest degree term. All right, so it's important to realize when we say leading coefficient, it doesn't mean it's the first term always. It means it's the one that's attached to the highest degree term. Constant term, that of course is the term that has no variable. Right? So if we're looking at these definitions, we might ask, okay, let's talk about one of these. For example, let's find our leading coefficient, constant term, and degree of the polynomial function r of x. Well, in r of x, we could say the following, that the degree is the power of the highest degree term. And of course, the highest degree term comes up first in this case. And so we're going to say that the degree right here is fourth degree. So this is a fourth degree polynomial. The leading coefficient is the coefficient that's multiplied by highest degree term, and if there's a sign in front of it, that must come along for the right. So our leading coefficient is -3 in this case. And of course, our constant term over here is the very last term, at least in this particular case. So we would say our constant term is -12. All right, so how do we add this up? Well, in this case, we're going to say that this is, if we were to classify this by its full name, r of x is a fourth degree polynomial in x with a leading coefficient of 3 and a constant term of -12. Okay, so this is the way that we would classify, fully classify our polynomial function. How about this one? Well, if you're looking at it and you're saying that the leading coefficient is 3, you would be incorrect. In this case, it helps to rewrite the terms in descending order of their powers. So if you rewrite this, you'll see exactly why we mean leading coefficient. The rewrite would be 4x to the fifth minus x squared plus 3x minus 17. So we've got 4 terms in our polynomial. The highest degree term is fifth, so it would be fifth degree. And it would be a leading coefficient of 4. And a constant term of -17. There it is, 17, right? By the way, you'll notice that there are a lot of terms missing. We can, for the purposes of writing our polynomial, we can treat those missing terms as 0 terms, and we very often do. So sometimes it is useful to rewrite this in this manner: 4x to the fifth plus the coefficient of the fourth degree term is 0 because there is no fourth degree term, as is the coefficient of our third degree term. We have a coefficient of 1, -1, for our second degree term, plus 3x minus 17. So when we see missing terms, sometimes we can replace them with 0 terms. All right, this is my brief on the definitions. A few examples to come up.